again, transition. I mean, I'm getting tone right here, right? Come on. We're on a 10-second delay, so I've got to wait for it to start. Test, 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 test. Oh my God, what the heck? I mean, you can see my oh, okay, there we go. All right, now I can hear myself on the stream. Sorry about that. And I will move OBS over. OBS just didn't like it that I started it before I plugged everything in, even though everything was perfectly fine. So to recap for the folks at home, this was not correct because it's the assignment operator. In C, it'll allow you to do it because it takes on the value 10, which is true. In Java, it doesn't even allow you to take on that value because this is the assignment operator. So good on Java not allowing you to do this syntactically. This is syntactically correct in, it's actually syntactically correct in both languages. It's just that in Java, you can't use an integer as a true or false value. In C, you have to use an integer as a true false value, or numeric type as true false, 0 being false, and anything else being true, okay? So now I think that we're all caught up there, right? And I will go ahead and cut and paste this out. All right, the above will compile and run, but it will give bad results. It's the assignment operator, it's not the equality testing operator. The mistake is not even possible in Java, right? So keep an eye out for such things and use a good font, right? If you have a tiny font or a non-monotype font, monotype fonts are fonts where every character takes the exact same spacing, then it can be hard to miss those kind of things. But again, I'm going to show you a tool later on where you can solve that problem basically. Let's look at one more pitfall and consider the following piece of code. So what is this going to print? It depends on A, right? Actually, it doesn't. Let's go ahead and go over here to C. And I will keep A at 5 here. All right? So is this going to print that A is 10? It's not, right? But let's go ahead and run it and see what happens. A is indeed 10. This is not the assignment operator. I didn't make the same mistake twice. So what's the mistake here now? Yeah. The semicolon, right? A misplaced semicolon. Remember that a semicolon ends executable statements. So as we go along here, this is perfectly syntactically correct. If A is equal to 10, then what do? The next executable statement, which is nothing. The semicolon, just like a period in a sentence, ends that executable statement. It's equivalent to kind of like this, or this, I should say. Right? So it's not going. So in other words, it goes on to execute the next block of code, which is this. Regardless of the value of A, it's going to execute that block of code. So let's take this over to Java and see what happens. Oops. And of course, oops, my formatter tried to warn me about it by doing this, system.out.printf. Right? It just looks wrong too, right? I mean, you can see it, wait, what, the semicolon, that shouldn't be there. You've got to be careful though, because even the best of us can miss punctuation. In fact, there was a persistent bug called the go-to-fail bug in Mac OS that basically you could circumvent a lot of security because of this bug was in there for 10, 15, 20 years, however long it was, because of the missing, I believe, 1 colon, right? And it was really hard to see, and that's why it went unfixed for such a long time. So, of course, same issue here in Java. It's going to print out that A is 10 even though it's not. So be careful, right? An empty code block may or may not execute, but the code block in curly brackets is not what we call bound to the if statement. What's bound to the if statement is an empty statement. It's possible in both languages, and it's always possible to tell the computer to do nothing, right? We call that noop or nope, no operation. And that's perfectly fine to tell a computer, do nothing, do nothing, do nothing, right? Now, my computer is sitting here idle, but it's certainly not doing nothing, but it's re-rendering the screen every millisecond or something like that. It's checking, there are a bunch of processes in the background, but it is certainly possible to tell a computer, don't do anything, right? So that's what we've done here. How can we save ourselves from ourselves? By checking all this stuff out. So what I'm going to show you now is a nice tool called a linter. And this is mostly going to be for C, because a lot of these problems are not apparent in Java because the compiler checks it out for you. Make your life easier by using proper GCC flags, right? So what is lint, colloquially, right? Well, the shirt is clean, but if I've got a dress shirt on, I put it through the wash, yeah, it might be clean, it might be wearable, it might be presentable, but when I put it on, what might I have, especially if I didn't put it through the dryer? Exactly, lint, right? Little pieces of fabric that you don't want on there. So what do you do to make yourself nice and presentable? You take a lint roller, right? Which is just an adhesive tape, and you roll it over and you make sure that you get all the lint off. Right? It was clean before, it was fine, you can go out in it and nobody's going to criticize you for having lint on your shirt, but you need that one extra little polish there to make it look fine, right? So it's not necessarily dirt, but it's, in the context of code, it's just things that look wrong, right? It's things that are potentially wrong. A linter is basically a static analysis tool. A static analysis tool is simply just a tool that looks at your code before it compiles and starts looking for these red flags, like, that doesn't look right? That looks like lint. You may want to take another look at that because it may or may not be a problem. You take another closer look at it and you say, oh, okay, yeah, that is a problem. I need to fix that. Or, no, that lint is fine. That's not lint, that's supposed to be there. So I'm not going to take a lint roller to that thing. Right? It looks for suspicious looking code, not code that is necessarily bad, all right? But that could potentially lead to bad things. So let me go ahead and show you a demonstration here. I'm just going to go ahead and go to my account on CSE here. And CS1, miscellaneous demos. I called the file linty, right? Now, this is basically just a toy program here. It doesn't do much, but I've introduced a lot of lint, a lot of bad things that are not necessarily program killers that will mean that my program can't run, but certainly things that are going to cause, some of them are going to cause issues, as we'll see here in a second. So I just declare a bunch of variables, whatever. I go A divided by B, well, that's D. C is A divided by B, which is 10.5 and 20. Okay, so that's going to be somewhere around 1/2, a little bit more than 1/2. 0.5 something, something, something. And so when we print it out, then we print it out down here. Scanf, okay, we read something in from the user. We read in on integer, right? All right, hey, there's that last pitfall that we just took a look at. Here's another pitfall, the one that we started with. Here's another pitfall that we left off Thursday with, right? So let's go ahead and compile this thing. The compiler was perfectly happy, right? No errors, no warnings at all. So, but when I run it, C, was that supposed to be 0? Remember it was 10.5 divided by 20? No, wrong answers. Right now it's expecting me to read in X, so let's just go ahead and give it X, 10. Segmentation fault, right? Had to think about it for a while too, right? I wonder if I ran it again, would it have to think about it again? Yeah, weird. I don't know why it needs to think about it, but there's lots of issues here. But the compiler doesn't care about any of them. Compiler, again, C is the kind of language that if you want to shoot yourself in the foot, it'll ask you what caliber bullet do you want. Java is a little bit more forgiving. Java is going to say, are you sure you want to do that? We can make it more like Java by turning on what are called warnings. Now, this is not the wall flag, but people call it the wall flag. It is capital W for warnings. Print them all, right? Now it lights up like a Christmas tree, right? there's a whole bunch of problems here. For example, when I printed out C and I got 0, it was the wrong format. D was an integer, and I tried to treat it as a floating point number, so because I've got the wrong placeholder here. Another issue here is scanf. What magic do we do with scanf? That's magic right now. We'll understand it later. What do I always do with scanf? Put the ampersand there. There's no ampersand here, so it's warning me about this. And that's actually what was causing the segmentation fault. It was a memory access error. Warning, if clause does not guard, blah, 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 this assignment, but the latter is misleadingly indented as if it were guarded by the if, right? Meaning that, wait, that semicolon there, that probably shouldn't be there because you probably meant for this code block to be associated with that if statement, and it's not, right? So warning about that. That's probably lint, and it certainly is. We suggest parentheses around assignment used as truth table. Oh, yeah, that's an assignment operation, not an equality there, right? It's warning me about that now. And warning comparison of 10 with Boolean expression is always true. You can't do it like this. You need to break it up into 2 statements. It's warning me now, right? Comparisons like x less than or equal to y less than or equal to z do not have their mathematical meaning because this is not math, this is code, all right? Unused variable foo, c, and y, those are lint, but they're not showstoppers. Just having an unused variable is bad design, but it's not necessarily going to kill your program. So yes, go back, fix those. Those were temporary variables that I no longer need because I was debugging. Okay, fine, I'll go ahead and get rid of those. Make sure that all of your submissions are free of compiler warnings. Otherwise, it will ding you on your design, right? On your assignments, of course. We'll make note of it for your labs, but we won't ding you on that for the labs. Labs are for completion. Nice tool, right? Yeah, go ahead. For your labs, we're not judging you on your style or your design, just completion. But certainly that's part of the rubric for assignments. Right? Okay? So, best practice, always use the wall flag when compiling. Right? Now, there are a whole bunch of, oh, did I misspell something? Oh, folgs. There we go, thank you. All right, spell checker can be checked later here. But there are a whole bunch of tools that you can use that are called static analyzers, and there are also dynamic analyzers. A static analysis tool is always going to be looking at your code itself before it compiles. A dynamic tool is going to be looking at your code as it runs, because it's dynamically running, right? Those 2 words have a special meaning in that context. Static means before compiling, dynamic means after compiling, right? And there are a whole bunch of tools that you can use at your disposal for static analysis or dynamic analysis too. When we get into debugging, a debugger is a dynamic analysis tool. A profiler is a dynamic analysis tool that allows you to find out, are you using memory resources properly, et cetera. Right? We'll go ahead and take a look at those later on though. So, short-circuiting is the last thing we need to talk about as far as conditions and Boolean values and logic is concerned, because it is not. It is something that is, again, particular to programming. So, consider the following logical AND statement. Right? If A evaluates to false, does it matter what the value of B is? Right? So, does it? No, why? Because for an AND, a logical AND to be true, both operands have to be true. So think back 50 years ago where you measured CPU cycles in several per second rather than the gigahertz that we have today. Right? If you could skip a CPU cycle 50 years ago, you did it, right? So if you evaluate A and say, oh, it's false, I'm not going to go and even look at what B is. I'm going to skip that CPU cycle and save, right? Now I've made my program faster. 50 years ago, it mattered. Today it doesn't matter so much, but every programming language, nearly every programming language does this. It skips the evaluation of the second one because it is familiar. Most programming languages started out, C started out that way, so all programming languages are expected to have that behavior. And it's called short-circuiting. So, no, the value of B will not change the value of the expression. So it is ignored. Right? This is known as short-circuiting. Right? The process has been short-circuited. Just like a short circuit, when you've got a circuit here and a light bulb on one end and a battery on another end, and then you put a wire inside of your circuit, you've shorted it out, and now the light bulb no longer lights. Likewise, your expression, if it shorts out, then we're not even going to bother to check the light bulb to see if it's on or off, right? Or anything like that, because we want to save CPU cycles. And even to this day, it still is a little bit of an optimization. Compilers will do most of the work for you of taking away little tiny optimizations of CPU cycles, but you don't have to worry about that anymore because our compilers are so good, right? Consider the following logical expression as well. Consider a logical OR, and then ask yourself the same question. If A evaluates to, slightly different, to true, does it matter what the value of B is? And the same exact answer is no. The value of the expression is true regardless of B. So it is not evaluated. It's important to understand that short-circuiting happens. It's not that big of a deal now, but when you get into more complex expressions, and one of the expressions, say, is an operation or a function, that function ends up not getting called if you have short-circuiting. So it's important to understand the ideas because a lot of programming and coding, what are called design patterns or idioms, are based on the assumption that you have short-circuiting. In real life, what is an idiom? Idiom. So this is now turned into an English class for 10 seconds here. Oh, out of the frying pan into a fryer. Something that doesn't have a literal meaning, but is a metaphor, a colloquial metaphor. Right? It's raining cats and dogs, right? We don't mean that it's literally raining cats and dogs. It's an idiom that means that it's raining hard. It wasn't raining hard earlier, but it was raining. Programming idioms are just like that. There are lots of idioms. There are lots of little things that have special meaning in programming languages that is understood only if you know that language. Like only a native English speaker or somebody who is learning English and then picked up an idiom book would immediately understand that, right? So it's in the context, we also have programming idioms, things that only make sense once you've gotten into the language, once you've gotten into programming for a certain amount of time. They're just colloquial metaphors and design patterns and things that are used all over the place that after years of programming, you just take them for granted, right? Just like you take the phrase, it's raining cats and dogs for granted. If you're speaking to somebody who is just learning English, they would look at you like, what the heck are you talking about, right? They wouldn't know those idioms because they didn't grow up with them, right? And programmers expect that behavior, again, because of programming idioms. There we go. I think we already talked about non-numerical comparisons, right? Or single character expressions. And I'll just go ahead and cut and paste it here just in case we didn't. In both languages, you can use, in neither language can you use equals equals for strings. Remember that. But you can use equals equals for single characters here. This is both valid C and valid Java right here. Why? Because of the ASCII text value set, right? Capital C here has a value of 65, 66, 67. Lowercase c here has a value of 99. And so these are nothing more than numbers. This is nothing more than a number. And so of course you can go ahead and use the equals equals operation here. You can use strictly less than, you can use less than or equal to with single characters because every character has a value associated with it according to the ASCII text table, okay? All right. I don't think we talked about how to resolve it, though. Maybe, let's at least, I'll come back to it. Let's see. All right. I don't want this one. I want a simplified version of this. Sorry, just a second. Let me get an exercise that I want to do really quick here. Exercise, there we go. So, write a program that reads in a decibel level from the user and gives the user a description of that sound. So if it's 0 through 60, it should be quiet. It should print out that it's quiet. If it's 61 through 70, it should print out that it's conversational. Right? 71 to 110 is loud. 111 to 194 is dangerous. And what do we do about negative decibel levels? First of all, those don't exist. And 195 and above, we don't have, that's not according to our specifications here, so how are we going to handle that? Right? Do we want to do this in C or Java first? No particular preference? Okay. Oh, okay, Java. All right, I'm going to go ahead and create a new class. What should I call this class? Decibel? Right? Decibel level, right? Except that name is discouraged. By convention, Java types usually start with an uppercase level, a letter, right? Decibel. Follow those correct styles, right? All right, let's finish that up. Also, it automatically put it into this package here. I believe on your first assignment, you need to be putting it in the default package, which is just up here. So let me show you some IDE tricks here. I can go ahead and drag and drop this around if I really want to. I'm going to move this up to the default package. When I do, okay, this version is just cut and pasted, basically. I still have these. If I wanted to move it, I would have had to do something else, apparently, but so be it. I'll have two versions of this thing. What did it not put in for me that I need to put in, especially for my assignment? Documentation. Automatically fills in the author. It'll probably do that for you too. We need to identify what this program does. Why did we write this? So I wrote this. I wrote this on, it's August now, August 1st. And this program reads in a decibel level from the user and prints out a description of it. Okay? Wonderful. What do I need now? What does any executable program need? A public static, in Java it's going to be public static void main string args. We'll go ahead and prompt the user for this input. Right? So system.out.println, enter a decibel level. There we go. Okay. How do I read input in Java? From the standard, the standard keyboard, the standard input, mashing keyboards. How do I do it in C? Scanf, right? How do I do it in Java? System.in with a scanner. Right? Scanner S is equal to new scanner. Very, very similar, right? Scanf, scanner, right? And system.in. It's going to complain about that because I need to do an import. I'll let the IDE do it for me. And it takes care of that. Okay? All right, so s.next, I don't know. What should we read in? Should we read in an integer? Or should we read in a double? Decibel levels can, you can have like 10.5 decibels. The specification doesn't say so here. So what should we do? Dealer's choice, right? Do whatever you want if it's not in the specification. And unfortunately, that's what happens in real life too. When you're designing software, you go through this phase called requirements gathering, or sometimes it's fancily called requirements elicitation, because you're eliciting requirements from the user. Like you'd go back to the user and say, well, should you be able to enter in, like, say, 10.5 decibels? And they'd say, no, we don't care about that, or oh, just round it off to 11. And okay, then I'll go back and I will design it to be an integer. Right? and that you'd have that back and forth. Otherwise, if somebody has already signed off on the specifications and the requirements and they didn't specify, great, do whatever you want, and at the end of the day, when you deliver the software, you say, it conforms to the specifications. You screwed up the specifications, not my job, I'm out of here, right? Of course, you don't want to do that. You want to be more diplomatic about it, and that's why maybe we'll go back and do some more elicitations and ask them what really happens here. And when I was in industry, we did this all the time. We called them bits. We need to go talk to the bits. That was not our term, team's term. We need to go talk to the butts in the seats, right? The people that actually do the work and use our software. We need to go have a conversation with them and ask them, is it possible to route this delivery from this station to this station over here? Yeah, but we never do that. Okay, well then we would go back to our product manager and say, it's very rare that we would support that. It'll take 50 hours of programming time to put it in. You make the call. Do you want that feature or not? Right? And it's all part of design elicitation or requirements elicitation or requirements gathering. Okay? So let's just go ahead and keep it simple. X is equal to s dot next integer, or next int, right? There we go. Is that a good variable name? X. What does it represent? Sound, right? Decibel. I should probably call it what it is. But then that gives me pause. Well, what about S, though? S is, I could write this in or input or something like that. It's pretty usual, though, to use something like S when it's just some generic object. I am just using this scanner in order to read in input from the user. So it's okay in that case, but it's certainly not okay in this case to do X is terrible, D is only slightly better, and decibel is probably the correct way to go there. Name variables what they stand for, okay? All right, now that I've got my decibel level, I can go ahead and start checking for things. Remember that my range here is 0 to 60, 61 to 70 conversational, etc. So if 0 is less than or equal to decibel less than equal to 60, then I will system.out.println, what was it, quiet? There we go. Oh, good, we started in Java, and Java is catching us on this. What's wrong? Yep, I need to split it up into two expressions here. Okay, fine, I'll do that. Here's a cardinal sin. Else if, what did I just do? I copy pasted. I'll do it again. Quiet, conversational. I'm going to do it. Oh, I'm just going to go ahead and do it really, really quickly here. Conversational, loud, dangerous. Okay, conversational, I need loud, I need dangerous. Okay, now I'm going to go back and change everything. It should be dangerous. It was, I guess, conversational. And the last one was what? Loud? Okay. And then it was, I have to go look back and forth. This is why you also want two screens. Or, like in this case, I've got 3 screens. At home, I always have at least 3 screens. A laptop and then 2 larger monitors. Because, of course, you always have to have Netflix on one of them. Right? And so make sure that you always have 3 screens. That picture-in-picture does not look good. And so now I've already digressed. And where was my place? Okay, conversational is 61 through 70. There we go. Loud was 71 through 110. All right. And dangerous was 111 through 194. Okay. Or maybe it was 995, I forget. Right? What did I do? I did it intentionally. Copy pasta leads to spaghetti code. Spaghetti code is code that is, think about spaghetti, right? When it's dry and uncooked, then very, very nice threads, like that thread starts there and goes down there. Very nice and organized to a point. You cook it, and now it's all messed up. There is no way that you can follow one strand and find its other end. You don't want spaghetti code. You want nice, clean code. One way that you can avoid spaghetti code is by not copy pasta-ing, right? So what did I do? What was the issue? 71, right? Okay. Looks good to me. Let's go ahead and run it. Yeah, go ahead.
If you were to do this in doubles, how would you account for the space in between, like, say, 60 and 61 or 70?
Hold that thought. We'll get to that. All right. So 0, quiet. Okay. I'm convinced that it works so far. Am I done? Ship it? No, I just did one test. Right? What other kinds of tests should we run here? You probably want edge cases and corner cases. What I just did was I tested 0. That's the edge of this range right here. I probably want to test something in the middle of the range, and then maybe also test something at the other end of the range, another edge case. I should expect quiet here. Okay, that works. I should expect 60. Okay, that works, right? And wow, testing. Lots of testing here. Okay. This kind of testing happens all the time with like play testing and with computers, right? And with computer games, and they call it beta testing, play testing. And back in the day, they actually had an army of beta testers that would try to break the game and then make reports of bugs. Of course, they don't do that anymore, do they? What do? They release the game early, make everybody pay for it, and now you're paying to beta test for them, right? That doesn't sound right anymore, right? But that's what it is, right? So 194 should be dangerous. What about 195? Dangerous. Okay. Is that correct? No. Fix that bug. All right, fine. Now, start all over. Retest everything, because you could have what's called a regression. You go back and you fix up one bug. That may mean that you introduce 5 more, right? So go back, do all your testing and test over and over again. I'm not going to do it here because I don't want to retype all that stuff. Instead, that is a huge, strong argument for automated testing. And automated testing using a testing framework. For C, it's going to be CMACA that you might use later on, depending on which labs you choose to do. For Java, it's definitely going to be JUnit, right? And you'll get a little bit of exposure to that on your first assignment, because we've got this Capricar project that uses JUnit, and it reports all these tests. You don't have to write your own tests. You just have to run the tests that we already wrote. But you can go ahead and take a look and reverse engineer it and see how to use JUnit if you want to use it going forward. All right, let's go ahead and test that 194, dangerous, okay. 195, what's going to happen? Nothing. Excellent prediction. Likewise, what happens when we enter something that is invalid? -10. Nothing. Is that a good user experience? Probably not, right? We should probably take care of these edge cases and do something about it, right? So I'm going to add an else block here. That captures all other possibilities, right? And instead of printing out dangerous, I'll print out unknown, right? All right, unknown, and nobody ever watches. Has anybody ever seen Good, the Bad, and the Ugly? Tuco couldn't read very well. Uncut. There's no name on it, right? All right, great line, great movie. Go watch it. Right? Unknown. So let's go ahead and try that again. 195, unknown. Okay. -10. All right, unknown. And of course, we would want to go back and make sure that we didn't break anything by running our full suite of tests. Except that still doesn't seem satisfying. This is negative decibel values. They're invalid, right? There's no a decibel is nothing more than an air pressure measure, right, of how loud something is in atmosphere at 1 atmosphere. Of course, in a vacuum in space, there's no sound because there's no air pressure, right? So this doesn't make sense to have negative, but this still makes sense. It's a valid value. It's just that we don't know how to describe it. Might I want to treat these two cases separately? Okay. Else, how do I do that? Suggestions? Okay. You mean else if down here? Yeah. Okay. Else if, and then else. Okay. And what should I put in there?
It's greater than 195.
Okay. Then output unknown. Else system dot out dot println invalid. Okay. Got to be careful there. 194, 195. What about when it is exactly 195? Right now, what will it print? Invalid. Right? Why? Because this is my fall through. All of these are mutually exclusive. This happens, or if none of these things happen, then this happens down here. So I probably want 194 there. Okay? All right, comment online, you can have a fatal decibel level, of course, an explosion. I don't think... usually, but the air pressure differences can also kill you. Certainly, even if there's no shrapnel. Right? But anyway, not great to think about. I don't know. But now let's go ahead and make sure that this works now. 0, okay, quiet. -10, invalid. Okay. I would argue maybe you want to put this one first and take it up here, just to be consistent with your ranges. I also want to simplify this code. Let's go ahead and look at this code right here. Do I need to check the lower end on this? Do I need to have both of these checks here? So if it's between 0 and 60, then this will happen. Otherwise, it's not between 0 and 60. So I've come to this line right here. Do I need to check that it's at least 61? No, because I would never have gotten to this point to begin with. So I'm going to take that out. Do I need to check that it's at least 71? No, right? Because order matters here, right? The order that you check all this stuff is important, right? Otherwise, if it's greater than 194, then I print out unknown, now invalid, etc. Okay, let's make sure, again, that we don't have any regressions. 0 is quiet. 30 is quiet. All right, let's do something. Give me another one. 194 should be dangerous. Okay, 195 should be unknown. Okay, and probably want to check the other edge case, -10. I don't know. What's going to happen here? Conversational. Why? Because my refactoring up here, my rewriting and simplifying of this code has now introduced a regression, something that is now broken. So, -10, it's not between any of these, so it's not quiet. Otherwise, well, if is -10 less than 70? Yeah. So, order matters and how all your logic matters here. Now I am going to move this up here so that I'm consistent about the ordering, right? So if decibel is less than 0, then I will go ahead and print out invalid. Else if, and now I don't need this one here. I know that it's at least 0. If it's at least, now also if it's less than 60, then I can put in quiet. Right? And now this should work. I don't want to go back and retest everything, but we'll at least retest that one. Okay? Again, you want automated testing so that you're not doing this over and over and over again. Imagine that play tester in the 80s that had to fire up the game and play through the first 10 levels in order to play the 11th, to test the 11th level, right? That's why cheat codes were invented, so that debuggers could jump to a particular level without having to actually, play the game. The cheat codes were never intended for the end user, and it's a cheat. They were there so that you could do easy debugging. A lot of games shipped with the cheat codes removed. A lot of them didn't. Why? Because it's more work, right? I put those in there. It's going to take more work for me to go and take those out for the final product. No, never mind. Right? So that's why they stayed in. Yeah.
Would they have to test them again after the cheat codes were removed? Is that
Probably. I mean, if they want to do it proper, yeah. And nobody's going to be doing that. Right? Let's take this over to C and see just how easy it is to translate between the two languages as long as you've got a very, very simple program. Right? All right, I don't have imports. What do I have instead? I have includes. stdlib.h, stdio.h, and that's good. I don't have classes, but I do have a main, right? Int main. I don't have arrays of strings. I have int argc char argv. Right? I don't have println. Instead, what do I have? Printf. I don't have a scanner. Instead, I have scanf. What's my placeholder if I'm going to be reading this in as an integer? D, good. %d, decibel. There we go. And is that correct? What am I forgetting? Oh, we'll find out here in a second. Right? I don't want to have to reformat all this stuff. But there's no quick button that I know of on CS50 here. Should I be doing system.out? No. Should be doing printf. And now I need to put in my own end-line characters. But other than that, everything else is exactly the same, right? Printf, printf, printf. In fact, I would just do a regular expression find and replace on all this stuff. There we go. Printf, and then you'd want to go back and put in all these end-line characters because println does that for me in Java. Printf does not do that for me in C. And then, of course, I would want to go back and reformat everything. Return 0. Look good? Yeah.
You forgot to indent one of the printfs correctly at the bottom.
Oh, okay. Well, I forgot to indent a lot of things. Those are the finishing touches that I'll take care of those later. Yeah.
Also, is this like an acceptable form of copy pasta?
Yeah, I mean, since you're porting over to a different language, the compiler is probably going to catch any errors. So, just don't get into the bad habits. Or you can get into copy pasta habits, but then you need to make sure that absolutely everything is correct, right? And testing, proper testing, will allow you to catch those kind of errors. All right, it ran, or it's going to run. Oops, sorry. GCC decibel. There we go. Okay. What is that warning me about? Here the WAL flag might be default, right? What's wrong? Decibel is uninitialized in this function, okay. And what is it warning me about here? For scanf. Ampersand. All right, fine. Thank you for warning me, WAL, or wall. There we go. 0, quiet. -10, invalid. Do all the same testing as before. 120 is dangerous, et cetera, et cetera. Okay? So, almost a one-for-one, line-for-line kind of translation between the two languages. Okay. Let's see. What else? Short-circuiting. What else do I want? Okay, we have enough time. Let's talk a little bit about comparing strings. This is a preview. Because usually I wait for strings for later on. So again, in neither language can you use equals equals to compare strings. You are comparing memory addresses, not the contents of the string. Okay? So you have to use something else. What about Java? So A dot equals B returns true if the contents of A and B are the same, case sensitive. Right? Just get used to it. In computer science, usually everything is case sensitive. In fact, you'll get so used to it that if you ever encounter something that's not case sensitive, you will immediately recognize it as wrong. I can't tell you how many people we've had to help in various sections that have not even using case-sensitive usernames or case-sensitive passwords. I don't know, maybe like on Twitter, like hashtags or whatever you use, those are case insensitive, but that's because they're catering to the general population, the normies. We're computer scientists, we know the difference. Everything is case sensitive, period, right? So you have to be careful that this is comparing them case insensitive. If you want to, you can go ahead and compare them without regard to the case sensitivity using equals ignore case, A dot equals ignore case, okay? Or you can use something even better. You can use compare to. And this is what's called a comparator pattern. It gives you even more information. A and B, equals and equals ignore case, it can only tell you are they the same or not. It can't tell you what order they go in. It goes apples and then zebra, or zebra comes after apples, right, etc. So let's go ahead and take a look at an example here using the compare to. And I'll go ahead and write up the code here. I want to go back to demo here. There we go. Let's go ahead and create some strings that we can play with. String A is equal to apple. I'll go with lowercase a here. String B is banana. There we go. Oh, thank you. A dot compare to B. Now, you have to understand what a comparator pattern is. This is not a logical expression here. This is returning a value. It's returning something negative if A comes before B. It's returning something positive if they're out of order, and it's returning 0 if they're equal. Right? So I need to check for the actual value that's returned. Compare to 0, then I'll system.out.println A is equal to B. Yeah, we're good on time. Else if A dot compare to B is less than 0, then that means that A comes before B. Comes before B. Otherwise, comes after B. Right? The only other possibility here is what? When you do the comparator, compare to B, it's greater than 0. Right? So this is a pattern that you'll see all again and again and again, where I need to know, how do these two things go? Does it go A and then B? Or are they out of order, and I need to put them in order? Or are they equal? Returning something negative, something positive, or 0 will tell you the relative ordering of those things. So does apple come before banana? Yep, apple comes before banana. What if I switch them around? Banana comes after apple. Right? Apple and apple, comparing apples and apples. They are indeed equal. Apple and apples. Which one of those comes first? Okay, apple comes before the pluralization apples. Yeah, why? That's how you'd order them in alphabetic order, right? Because this is the shorter string, it matches this string up to that, and okay, this is a little bit longer, so that goes next. Okay, let's go ahead and put that back. Apple and apple. Which one comes first? The capital A apple or the lowercase a apple? Apple, lowercase, comes after apple, uppercase. Okay, why? Do you remember the ASCII text table? ASCII table. ASCIItable.com. Where do the capitals come? A through Z before lowercase a through Z. Okay, so that kind of makes sense that uppercase A apple would come before lowercase a apple, but then you get into weird stuff. For example, banana and apple. Banana. There we go. Which one comes first? Banana comes before apple. Does that sound right? Dictionary-wise? Open up your dictionary. Does banana, regardless of capitalization, does that come before apple, A, apple? No. But it does with respect to computers because of the ASCII text table. All of the uppercase letters come before any of the lowercase letters. And so consequently, you've got to be careful here that banana will come before apple. What about 1024 and 500? There we go. Which one comes first? If these are numbers and you were ordering them, what's the natural way of ordering these things? 500 comes first, right? Because it's smaller. These aren't numbers. These are strings. 1024 comes before 500. Why? It looks at the first character. 1 comes before 5 in the ASCII text table. 1 comes before 5. So, since they're strings, it's going to order them as strings. This is why we don't call it alphabetic ordering. We call it lexicographic ordering, right? And 500 does not come before 1024. If you want to treat these as numbers, you need to make them into numbers, x and y, and then call integer.parseInt. Okay? All right, I'll make sure that this is, at least this chunk here is in the notes. But things to remember. Usually orderings are lexicographic and all that entails. So Java here. There we go. And I will repeat that it follows this comparator pattern. The comparator pattern is if A comes before B, is strictly comes before B, then it returns something negative. Don't pay attention to the magnitude, right? It could be -5, it could be -1 million. It doesn't matter. The only thing that matters is that it is negative. If A is equal to B, then it returns 0. If A is greater than B, in other words, they're out of order. If I write A, B, they're out of order. It actually goes like this. Then it returns something positive. And that makes sense because think of the number line. Negative comes first, then 0, and then positives after that. So just remember the number line. Negatives come first, then positives. And that gives you the relative ordering of A and B when you use this comparator pattern. In C, you have almost exactly the same thing, except that it is, here, I never cut and pasted it. Okay, sorry. Copy, paste. There we go. Now it's in the notes. Right? It's not well formatted, but so here. There we go. Okay? In C, you don't use compare to. You use this strcmp. What do you think that's short for? String comparison, right? Again, 50 years ago or 40 years ago, whatever, if you could save a few characters, you did because your hard drives were on the kilobytes instead of megabytes. In fact, I was many years ago, I was at the Computer Museum in, I think it's in San Diego. There are probably several computer museums, but there was one in San Diego. They had the first hard drive. It was like 8 feet tall, and it had a whopping like 4 megabytes. right? And it was huge, right? It was actual, magnetic disc that big, and it only had 4 megs, but it was huge at the time, right? Very, very nice. They have all their main exhibits. When I went there many years ago, they had all their main exhibits on the first floor, and it was all fancy and everything, intended for actual, just normal people coming in and taking a look at stuff. If you go in the basement, though, that's where they put all their overflow exhibits. They just threw everything into the basement, and you could literally go up and play with this stuff if you really wanted to. There's a curator there, and there was a program running on this really old computer. It was printing things out, and he even let me sit down and type at the terminal and everything. So it was a really cool experience, but really, really old school stuff. Right? All right. Know that it is in the string library, and we'll revisit this later on. Let me go ahead and, just for completeness here, let's go ahead and translate this over to C. All right? Does C have strings? No. Preview, we're not there yet. The way that you do strings in C is a character array. Char, instead of that's a single character, that's a character array. Right? You don't have compare to, you have strcmp of A, comma B. And if that's 0, then they're the same thing. If it's less than 0, then A comes before B. If it is greater than 0, then B comes before A. A comes after B. Right? I think that's the same thing. Just a different way of saying it. Printf. Now here is a gotcha. You can't this is called a string concatenation. In Java, you can take a string and another string, or anything actually, and concatenate them together to form a new string. You cannot do that in C. Yeah?
So how is that, I reckon you can't just use this string comparison itself as a Boolean in C, because if A and B aren't equal to each other, it won't print.
Yeah, you can't do something. I mean, you could do something like that, like A is equal to B, but again, that's a memory address. Right, so, and it will not, it'll end up probably always printing out that they're not the same because they're 2 different memory addresses. So how do you actually print strings? %s is your placeholder in printf, right? And %s comes before %s and the line, and you just have to print them out in a comma delimited list here. Printf %s comes after %s and the line B. B. There we go. All right. GCC demo. Oh, what's wrong? Oh. Syntax error. There we go. In fact, I could go ahead and no warnings, right? Just get into that habit now. I'm not into the habit of typing that when I do demonstrations like this, because I usually do everything on my Mac, and my Mac has been configured to always list out all of the warnings. In fact, when I put together my videos, I had to go in and change that so that I could have the reveal at the end that here's the Christmas tree lighting up now with all these warnings. So let's go ahead and run this. And we'll see that we get the same output, that 1024 comes before 500 because of lexicographic ordering. Okay? All right. All right, any questions? Yeah?
Do you have to download the CMOG and like the Java thing in order to complete the assignment? Because
No, I mean, you will need, okay, so let me do mention that you will need Git of some sort. So, what do I want to say about that? So, first of all, I think I posted on Piazza, but otherwise, if you go to my channel and you watch video 1.2, and this is in module 1, getting started, quick introduction to command line Git, then I believe then everything should be okay over here. Like if you just go ahead and, oh no, where's my CS? Oh, there, here we go. All right, I'm just going to go ahead and make directory assignment 1. There we go. So I think it's, what is it, Capricar project? GitHub Capricar project. There we go. So the first step is that you're going to want to clone this. And I don't have the clone button here because it's mine. I imagine if I opened it up in a private window here where I'm not logged in, then I can go ahead and, fork it. Where's fork? There we go. You can fork it. Then you'll have your own copy on GitHub. Once you've forked it, then you'll want to clone it. And I'm going to clone my own. Of course, you would not want to don't clone mine because you can't make changes to mine. You'll need to fork it off into your own copy on GitHub. Then you can go ahead and clone that down to your regular computer. If you watch video 1.3, we walk you through that process. All right? And git clone HTTP S, there we go. And there's the Capricar project. Now it's all in there. There's a C version, and then there's a Java version. So I'm doing let's do the C version really quick, or just get you started here for the C version. The README file that's available on the web on that repository will walk you through how to run it. Make Capricar demo, for example. Make Capricar demo. All right, so already a bunch of errors, right? Syntax errors, linter errors, etc. You're going to want to go in and fix those things. Once you fix them, like you change something about it, then you'll want to commit that change and push it out to your repo. Again, that's going to be video 1.2, getting started. I show you how to go through that using the CS50 IDE. You'll do that for the C version. Then you can clone over here in, I don't have a video for this, so that's why I'm showing this to you now. You might have this Git up here, right? If not, then you can always add the perspective. Let's see, what is it? Oh, no, there's a plus button right here. So if you don't have that Git perspective right there, then you can add it. Once you've got that Git perspective, then you'll follow the exact same instructions that you follow for your lab, for cloning, right? You'll, what is it? This, I think, create a new, no. Clone, there we go. Clone a repository. And so what was it? There. HTTP S, there we go. Right, of course, you do not use my URL. You would use your URL after you've cloned, or after you've forked it off. And then you would have it just like you would a lab, and you'd go and you would make changes to it, but you'd end up pushing those changes. For example, I've got changes right here. What are the changes? History.
Wait, how do you push them again? Sorry.
Git tutorial. There we go. This is what was posted on Piazza, where I can open it really quick. Where is it? I just downloaded it. Okay. Git tutorial. Move that back over to there. There we go. So introduction to Git. Using it from the command line, of course, I walk you through in the video. Otherwise, what about Eclipse? Cloning an existing repository, creating and sharing your own project. You don't have to do that because it's if you clone it from GitHub, it already exists. Making and committing and pushing changes. So all you have to do is skip steps 1 through 4 and skip at step 5. Right? So nice little pictures everywhere too. Believe me, I've spent plenty of time in not Photoshop because I'm not going to pay for Photoshop, but GIMP, making all of these nice little pretty pictures and highlighting them and stuff like that. So go ahead and use them. Somebody posted on a question, not really a question, but a solicitation for a partner. So if you are looking for a partner, you still have, I think that there are still 4 open posts on Piazza of people looking for partners. You go ahead and team up, right? So if you're online, make sure that you're doing that in the main room there. Otherwise, any questions? Remember, it's due this Friday at midnight, so I would get all 4 of those initial programs done as soon as possible, and then team up. You still have to team up with somebody for the GitHub part, at least part of it. So no matter what, you're going to have to find somebody or create a second account for yourself. Don't do that. That would violate the GitHub terms of service. But otherwise, you will need to create you do need to create a repository. Now that I remember, it's just a Hello World repository. You print your name and major, you get somebody else to contribute to your project, and you push and pull from each other. Pushing out means that you're pushing it to the remote github.com, basically. Pulling means that you're pulling in changes. So if person A, person B, they push changes out to a common repository, they pull each other's changes so that you can make changes, and then those changes are shared by this person by them pulling. Push, pull. Fork is something different. Fork is not even Git, that's just GitHub. Forking means you're cloning it, but not locally on your computer. You're cloning it on GitHub servers. Okay? You have more than enough to complete assignment 1, so make sure that you're getting started on that. We do have office hours, of course, throughout the week, but not late night Friday if you're the type of person to wait till the very last second. Okay? All right. Then I will see you on Thursday after Lab 3.